Hello guys, welcome back to our channel. So the topic of today's discussion will be estimating value at risk through E GARCH considering a normal distribution. So if you guys could remember, in our previous video we have calculated value at risk through GARCH 11 and assumed students T distribution. So in this video the estimation will be for E GARCH. So few things or the few matrices in this estimation will be different, so we'll go step by step. So first thing, we have to calculate the residual square. So we'll simply copy this from our GARCH on students T's calculation. Residual square calculation will obviously be the same for each of the model you calculate. So I paste it here, converted it to percentage, and we'll drag this down. There you go. Now comes the part we have to estimate the variance, the long run variance. It will be the same long run variance I can pick from here, which is GARCH student T, and I'll paste it over here. Let me take the format. Now the standard deviation will also be the same. I'll again take the format. Now for value at risk, we'll simply multiply this, since it's a normal distribution, so we'll apply norms inverse, and the probability for 95% confidence interval would be 5%, and if I take the format, it will be this. Then I'll simply copy this over here for 97.5. So for 97.5, the probability, the significance level for probability will be 2.5, which gives me this. Now the next thing, for 99%, this will be 1%. There you go. I'll take the format. Now the last one, which is 99.5%, for that the probability will be 0.5%. So done. Now comes the next bit, where we need to calculate log var. So this would come straightly from our eViews estimation. So let us go to eViews. I'll open my eViews screen. This is the screen. So I'll click on quick estimate equation. From NLS ARMA, I will make it arch, and I will type my equation, which is return space C, and from GARCH TARCH to I move it to E GARCH. So I made it E GARCH, and everything other things stays same. I'll click OK. So this is the E GARCH generation, E GARCH output. So I'll go ahead, and I can see over here the coefficient that are generated is 1, 2, 3, 4, C2, C3, C4, C5. So there are 4 coefficients. So I'll write them somewhere here. C2, C3, C4 and C5. I write their values over here. Okay, copy. C3 is value, C4's value, sorry, C4's value and C5's value. So all the values are copied. Now I will copy the E GARCH equation, which is this. I'll keep my equation on top, let's say here. So this is my equation. This looks like fairly a bit of long, by size it's a long equation, but it's simply easy. So the equation states simply log of GARCH, which is log of variance basically, which is equal to C2, which is this coefficient. So I'll copy this, paste it here. Then it says C3, I'll copy C3 plus C3. Then it says C3 is multiplied by absolute of residual t minus 1th data point divided by square root of GARCH t minus 1th data point. Now guys, this thing over here, square root of GARCH t minus 1th data point simply means standard deviation of t minus 1th data point. Since GARCH t minus 1th data point means variance of t minus 1 data point, so square root of that would simply be standard deviation of t minus 1 data point. So we'll simply go ahead and estimate our equation, which states C3, which is this, I will enclose this in brackets, C3 multiplied by absolute, I will give absolute residual t minus 1. So our residuals are probably this, because this cell is residual square, so this is residuals. So t minus 1 then divided by standard deviation t minus 1 data point. So my standard deviation is simply this, and then close brackets. So I keep this conjugate in another set of brackets separately, so I put one brackets less, so that's why Excel itself corrected itself. So okay, so we are done with the second part. Then the next set says C4 multiplied by t minus 1 residual divided by again square root of GARCH minus 1 or standard deviation of t minus 1 data point. Now I will copy the C4 coefficient, go ahead and paste it over here, and it says this thing, I will enclose this in brackets, okay, and multiply this with residual t minus 1. So residual t minus 1 will be this, So residual t minus 1 divided by standard deviation of t minus 1 data point, which is this. Now I will keep this in brackets and place another bracket to close this conjugate. There you go. Now the next term says C5 coefficient, which is this. I'll copy this, plus C5 coefficient, let me enclose this in brackets, multiplied by log of GARCH minus 1. So I'll do the log. So log of GARCH minus 1, or the variance. The variance is this, and it's asking for base, so we'll keep the base as 10 and close this bracket and another bracket to close this thing, and press enter, and express this as a percentage, so it comes as 496. So okay, so we got our log of var. Now log of any number, say log of x, is simply, if I convert this into index form, say for this my base is 10, log of x has a base of 10, say for example, then 10 to the power of x will simply be its index format, right? Similarly, this is log of var to the base 10. So if I want to convert this to var, that would simply be 10 raised to the power of this value, right? Convert this as percentage, it looks like this, and other things remain same, the standard deviation, value at risk at all the confidence intervals. So you can copy this thing from the top, from EG till AK cells, and paste it over here. So our value at risk is calculated. Now I will simply go ahead and copy this and drag this thing down. There you go. So our value at risk is computed for E GARCH at all the confidence intervals from 95 to 99.5, considering a normal distribution. So that's all guys. So I'll delete every other thing that I have punched over here, maybe delete the equation as well, the value of the coefficients. Okay, so this is done, value at risk with E GARCH. So I'll move to the top. Yeah, so that's all for today's video guys. In the next video I will compute the same methodology, that is E GARCH, but I will assume a student's t distribution rather than a normal distribution. So that's all guys from today's video. Stay tuned for the next video, and do share, subscribe and like our videos if you like them, and do comment down below. Thanks guys.